And we are live. Not sure how this is going to work, but I'm trying this for the first time. We're here with Mark Sokol of Falcon Space, and we're going to try and do some work, but
That was from my end. Go ahead.
all right, making sure. So we have a cool. I want to share this video file or the screen share. Hold on.
Basically, we're going to be checking for anomalies that happen in crystal growth during a three-body alignment, such as a lunar or solar eclipse. And to do that, we have cast earlier last week, we've cast several different ingots of bismuth and a lead tin alloy, and we're looking at the crystalline structure in them, and we carefully notated exactly when they were cast, so we have that information. And then we're going to be casting more of them today during the lunar eclipse to see any differences in the crystal growth. And the crystals should be, during a lunar eclipse, should be lined up in lines, which is very interesting that the moon, which is, hundreds of thousands of miles away, can actually affect crystal growth here on Earth. That shows that we really don't understand what's happening with gravity and crystals, which form on a atom by atom basis. And Jeremy actually pointed something out very interesting in the chat. Everyone, if you have some distilled water or even salt water, whatever, just stick it in your freezer right now. Let's see how the crystals in that cup grow during the lunar eclipse. A lunar eclipse lasts for 90 minutes, an hour and a half. So there might be enough time for crystals to actually form in the cup, during the eclipse. Preferably use cold water so it will freeze even faster. Also, something else.
Just admit that hot water freezes faster than cold water. Cold water, there's a myth that actually hot water will freeze faster, and it's because
that doesn't make any sense. But another thing that's supposed to be
no, they found out what it is that it triggers your freezer to kick on at a higher rate because the heat and that actually.
Well, just set the thermostat, I guess. That might be useful.
In any case,
another thing that's supposed to happen during a lunar eclipse is that the spectrograph that we see over here, the spectrum.
Mythbusters did the hot water and they couldn't explain it, but it proved that the hot water actually freezes faster than cold. But I don't know.
I mean, your theory makes sense that it was just kicking it on faster. But you see that spectrum of light over there? Now that is a prism separating out the light from a point, and we're able to tell through lines of points in the prism where there are no light what elements are being excited, and that's how we're able to tell what elements are in the atmospheres of other planets. Let's say during a three-body alignment such as a lunar eclipse, the effect is supposed to go up by 2 orders of magnitude, meaning 100 times more significant are the spectral lines in a spectrometer. So we're going to be looking at that as well. During the total lunar eclipse, we'll be putting this over the camera, and we'll see what kind of effects that have. Jeremy, how are you dealing there? I know you're at an undisclosed location for remote viewing of the eclipse.
Yeah, it's really cloudy here. I can kind of see the moon a little bit through the clouds, but I mean, I'm not even going to try to show you guys because it's just not going to come out with the camera. I would need a telescope and a real nice camera setup, and I didn't have any of that ready. So we're just gonna ride this out. The eclipse starts at 10:28 p.m. I think that's when it's peaking. I think it might start maybe a little bit earlier than that. I'm not sure.
I think it already started. That's like the first contact thing. There's different P1, P2, U1, U2. There's different contact points of the eclipse. The umbra and the penumbra, and then there's the greatest eclipse.
So I don't know. Maybe you could do a share screen on that video and play that video that we had.
Let me try doing that. Let me first get it to full screen mode.
Abnormal physical phenomena observed when the sun, moon, and Earth are aligned.
Okay, this is from Bob Greener, who hopefully will be joining us today.
Yeah, he was actually here in the live chat. Let me just go back. He was the first comment on the stream. It said it's 4 a.m. where he is, so he's not sure if he'll be able to make it. But yeah, there's a lot of weird things about people saying try your experiments during the full moon. I mean, and the eclipse, full moon and an eclipse. So yeah, we fixed the spelling of crystal growth in the title. Crypto Alchemist should be joining us at some point.
Let's say I'm just trying to move everything around here so I can get that into the right window. Okay, let me see if I can share it now.
Hey, thank you for the $10 super chat, by the way. Sorry we got off to a little late start. I'm working from the road here.
Okay, let me try this again. Try share screen. No. There it is. It says the browser can't access your screen. Maybe I'm on the wrong kind of browser. I'm on Firefox right now. Does this work better on Chrome or something?
Maybe.
Let me try logging out, and I'll log in from Chrome. I know we've had this problem before. One second.
For heavy on the pad is.
I'm gonna have to leave the studio for a sec.
I'm trying to find a live stream of the eclipse so we can show it. $11 p.m. That's not weird. Damn it, where's the there's a couple live streams here of the eclipse on this page. If people want to check that out, let me just find that. And there's Mark.
Hey, I'm back. I'm just gonna grab the link over here. Let me see if I can make this happen now. Share screen. Window. Firefox. What's that? I have to go to the preferences first.
Yeah, so we got this here. Watch it from New York. It's not gonna start yet. They're not ready. There it is.
Okay, are you seeing the video now? Jeremy, are you seeing the video?
Yeah, I'm just sharing my screen.
Videos.
Oh, so I have the video from Bob Greener. If you want to do that,
You got to share
44
your.
minutes long.
You got to share the window.
Share screen. Yes, I have the window there. No, window.
Chrome tab.
Yeah. There we go. It should be sharing now. Do you see it?
Oh, yeah, there it is now. Yep.
Okay, we're good to go?
Yep.
Okay.
Hi, my name's Bob Greener, and I'm a volunteer with the Martin Fleischmann Memorial Project. Today's video, I want to talk about abnormal physical phenomena observed when the sun, moon, and Earth are aligned. And this is part of a series of videos which are relating to the proposal to translate Alexander Parkhomov's book, which is here, Space, Earth, Human, New Concepts in Science, or something similar to that, by Alexander Parkhomov. And it's talking about, in one sense, gravitational lensing of relic neutrinos. And what I want to do is also talk about how the observations in this work may relate to Alexander Parkhomov's work, and also how these observations relate to some of the low energy nuclear reactions work, some work by the US military, and also work that we've shown you over the last couple of years. Some of it will be hypothesis, but I'd like to present these hypotheses and see if they resonate with you. So this particular article was given to me by a chap called Peter in response to one of the previous videos in this series. And it's an article from a journal or a magazine called 21st Century Science and Technology. And this is the fall 1999 edition. So I'm going to take you back to the start of the article, if I can. There we go. And essentially, this is by one Professor Xu Wenju from the Department of Physics, Huazhong University of Science and Technology in China. Next here is contrary to accepted theories of gravitation, the three-body alignment occurring at solar and lunar eclipse produce a measurable abnormal effect on force and time measurements. So these kind of things are discussed in here with Alexander Parkhomov's experiments. This is some work that was conducted in China, and the work it's saying here, the editor is saying that Professor Xu contacted 21st Century shortly after the publication of the work of Maurice Elias in the spring 1998 issue. So we talked about Maurice Elias in the previous video. He was he's a Nobel Prize winner and did studies on various types of pendulum to establish things going on in terms of cycles that may be related to gravity or some other type of force. Miller, this is the title of the article in the 1998 issue, spring 1998 issue, The Cover-Up, informing us of his independent researches in verifying the conclusions of Elias that the theory of gravitation should be developed. This article is his summary of several reports, both published and unpublished, covering more than 1 decade of experimental work. So, going into the meat of the article. During the period when three bodies, the sun, the moon, and the earth, are in an approximately straight line, there appear some inexplicable anomalies of physical character. These include an unusual force of horizontal oscillation, strange changes in the pattern of grain sequence in crystals, changes in wavelength of emission spectra, and changes in the rate of speed of atomic clocks. Since 1987, my collaborators and I have been conducting numerous observations and analyses of these strange phenomena. So, he then says, Beginning in the 1950s, scientists noticed some inexplicable mechanical phenomena occur on the Earth when Sun, the Moon, and the Earth line up approximately along a straight line. These are generally called gravitational anomalies. First, Maurice Elias discovered the azimuth change of paraconical modified Foucault pendulum during a solar eclipse. And so essentially, azimuth is essentially saying that, you know, if it's moving around like this, it will move around differently, and there's sort of be a slight change in angle during the eclipse or alignments of the Earth, Moon, and Sun. Then also during solar eclipse, Louis Quan Wang found an unusual inclination of a clinometer, an instrument that measures angles of elevation or inclination, as if a horizontal force of 10 to 20 micrograms was applied to the instrument. Thereafter, T. Kusela found an abnormal inclination from the plane of a torsion pendulum during a solar eclipse. E.J. Saxel discovered that a relative change of magnitude 10 to the minus 4 in partial cycle of torsion pendulum occurred during a solar eclipse. Yet others have found that the change for the entire cycle was 0. The following is a summary of some of the research of these very exciting physical phenomena that I and my colleagues carried out in China. So the first of these sort of family of anomalies that they investigated was abnormal horizontal force detected during eclipse. So he has this apparatus, it's well described. You've got a weight, a sheet of brass, and then you have some strain gauges to measure. And this box is to enclose the sheet that's being tested for strain changes in an environment that does not change its barometric pressure or humidity or whatever. So you can discount those influences. An eclipse of the sun took place on October 24, 1995 in the city of Kunming, China. It began at 10:22 Beijing time, reached its maximum at 11:46, and the second contact at 13:18. The maximum of the eclipse was 0.73 when the sun was at an altitude of 60 degrees. On ordinary non-eclipse days, curves are smooth and continuous. So here we have some examples of what you would see on an ordinary day. So there's no real sort of massive departure on this, the strain gauges and on this brass sheet. And of various ranges of temperatures. And he says, during the eclipse period of October the 21st to October the 28th, the curves changed suddenly from their original smoothness, with the change occurring right on the points of 900, 1042, 1500, and 1712 for all 5 days. Between 1500 and 1700, there's great oscillation with an amplitude that is partly symmetrical to the amplitude on the day of the eclipse. These curves do not manifest any sudden changes or oscillation before October the 23rd or after October the 28th. So the graph he is referring to is here. And so there's the period of the eclipse. And here are the sort of before and after days. So he seems to have replicated some sort of azimuthal, directional changes based on something that's going on because of an eclipse in this sort of gravitational body alignment. Now, that's a real physical effect, and it's similar to the physical effects that we talked about in the previous paper. In the previous presentation also, we talked about the fact that various researchers had established that there were biological changes during solar eclipse, and also that you could move things around and they would, like oysters, and they would open at the right time depending on the tide times in a particular part of the planet. The same oyster could be moved and it would kind of know when it needed to open for the tide where it's going to. Anyway, so The next area that he talks about is the effect of eclipse on the casting of lead-tin alloy. Another solar eclipse took place on December the 24th, 1992, whose maximum in Harbin City, China, was 0.61. Before the beginning of the eclipse, we melted the lead-tin alloy, tin 55, lead 45%, into a liquid state and maintained it at the melting point temperature. During the eclipse, we cast a group of samples using the lead-tin liquid alloy. After, we also cast another group of samples. The two groups were photographed by an electron microscope in order to examine their metallographic patterns. The control group shows a random grain distribution. The eclipse samples show a sequenced grain distribution. The conductivity of the two groups was also tested, and the results indicated that the conductivity of the eclipse sample was 5% higher than that of the control group. So it actually has here the two SEMs, and all the links, as ever, will be in the description of the video, so you'll be able to go and look and download these papers and look at them. But essentially, this is a sort of typical example from the non-eclipse cast lead-tin alloy, and this is from
Mark, what is that noise in the background? Some woman's talking or something?
You know, we have been suffering.
And you can see this is just looks like spots, and this has got some regular linear structures within it. So absolutely fascinating. You've got something that is changing crystal growth during an eclipse when you have the sun, moon, and earth aligned. Now, this one is really interesting for me. This is abnormal changes in emission spectra. It is well known that the spectral wavelengths of elements on Earth have proven consistent by all tests in the past. They can be altered in the universe only by the gravitational and Doppler effects. For instance, spectral wavelengths of the solar surface compared to those of the Earth's surface show a relative shift of 10 to the minus 6 magnitude. However, during the solar eclipse of September the 23rd, 1987, an eclipse with a maximum of 0.86, we found a relative change of 10 to the minus 4 in the magnitude of the spectral wavelength. So you have 2 orders of magnitude changing just due to an eclipse where anyway, this is really fascinating for me. So what they did is they used a variety of spectrum analyzers, and they photographed emission spectra from hydrogen, deuterium, calcium, carbon nitride, and nickel and titanium, and a selection of other things, and they go into this, but you can read it in your own time. Here, the results of our measurements indicate that spectral line spacings that are measured on any unusual day remain unchanged within the average error range, while a relative change of 10 to the 4 magnitude took place for all the spectral line distances of hydrogen, deuterium, calcium, carbon nitride, nickel, and titanium, and so on, photographed during the solar eclipse at different laboratories. It can be reliably stated that it is the solar eclipse which caused a relative shift of 10 to the minus 4 magnitude in the spectral wavelength. Now, when I read this, this really piqued my interest. I mean, of course, the notion of crystal growth changing due to gravitational body alignment is fascinating. And of course, the lead-tin alloy changing is really, really fascinating. Sorry, that is the same thing. But of course, the force changing here is very, very interesting. But for me, this really grabbed you. Why? I've got a little note here, and it says, could this explain the inability of EDS and XRF to determine elements in Lion, Echo, and Hutchison samples? So in Lion and Echo, when we tested under EDS at the university, Maastricht University here in the Czech Republic, There were areas and sample spots and areas which it basically could not determine reliably what they were, and you kind of had to do a rough best guess. The fact that there have been materials produced from his reactors that are not able to be determined what they are, or they're incorrect. They seem to be incorrect what they are. And actually, we experienced this on XRF testing in the lab Synthestech in Sochi, and we'll release that data as soon as it's prepared. But essentially, how deep it was through the terrestrial sample. And it's interesting this because this hadn't really been discussed, but it does appear that not being able to determine elements from low energy nuclear reaction sample ash is a big signature of the effect having occurred. And actually, after the Sochi week, I was sitting down at breakfast the day after the main week had occurred. And there was Anatoly Klimov. He was talking to another Russian scientist, and I just invited myself to the table. And the topic got onto the difficulty of demonstrating LENR. And one of the principal difficulties he was talking about was that sometimes it's just impossible to determine using standard technologies what the actual elements are that are in the physical thing you can see in front of your face when you hold it up to your eyes and you put it under the equipment. And I actually talked about this in a video I published on the 18th of January 2018 called Lion Tractor Beam. And this was a really important video for me to understand what may be going on with low energy nuclear reactions. So this is the outer crust, which seemed to be determined as Cu2O largely. It's a higher level oxide on the outside. But what was noticed, and hopefully this will be able to show you here, is when this is under diffuse light, whatever angle you look at it, it just looks silvery grey. But if you get a bright flash that's bouncing the light straight at the sample and back, some planes will report as this red color. Now, the red color is not surprising because essentially it's Cu2O, and crystals of Cu2O in nature are actually very red. And so here's the crystals in nature. But the interesting thing about these is they're red under diffuse light and flashlight, whatever angle it looks at. So this struck me as something really bizarre. Anyway, I'll leave the link to this presentation from the 18th of January 2017, because this isn't only what I found interesting. Later in the video, I talk about this, where with the closest elements that we could determine these large areas were ytterbium and hafnium. And these are absolutely not in the starting material. But it seemed to be that it was to do with some azimuthal change, i.e. depending on the angle. And I actually talk about this as vector fun, like this, you've got the beam from the SEM coming in, exciting these atoms, and a X-ray photon is coming back into the sensor. But depending seemingly on the angle, you are getting ytterbium or hafnium or oxygen or copper. But you know, there was only copper, and it's an oxide of copper. That's all we should expect to see there. And so I was, suggesting by the name here, tractor beam, that something is either slowing down or accelerating this light. And for me, the only thing that could have been is something that was, this is light we're talking about. So it kind of had to have been slowing or accelerating using something that could do that, which the only thing I could think of was something that acted a bit like a black hole. And this was compounded with something else. And at the time I published this video, I asked people to look at the data that was publicly shared that I was putting out, because there was more in this that needed a closer look. And what I was referring to at that time, I actually talked about at Sochi. And it was these structures here. And on the surface of the structure, we saw a 2-point, we saw a 3-point. On the outside surface here in these split planes. Now, the interesting thing about this is that this is ostensibly all essentially at the same angle, but within that same angled sheet, there were also these various elements, supposed elements detected. Here's a 4-point star, and here's a 5-point star. And by overlaying and doing some additive processes, you could see the structure a little bit more clearer than you saw on the straight supposed elemental view from the SEM. And you see these, what I call the yin-yangs, these like comet trails, like pairs, like you've got a black one and a bright one, a bright one and a black one, a bright one, black one, and so on around this 5-point with this point in the middle. So I'm saying that this, looked like it was some self-organized structure that was frozen in time at the point that this, and according to the line author, it froze incredibly quickly, and the data looks like it was freezing from around about what we now know is over 1,000 degrees to what appears to have been around about absolute zero in a few seconds. This structure seems to have been frozen in, but it beggars belief that this could actually be like these elements in these positions. And I'm thinking maybe there's some electromagnetic structures that are frozen and locked into place that were working on this material whilst it was hot, but got locked into place. And when the X-ray comes in and excites those atoms and the light comes out, they are influencing, bending the light or accelerating it or slowing it down such that it gets detected like at a different frequency. And as I said, in this, it's saying here that the only ways that this can really occur is essentially by gravitational or Doppler effects. Now, I'm pretty damn certain that this sample in the SEM wasn't traveling away or towards the detector bit by bit at large fractions of the speed of light, or certainly high velocities enough to change the frequency of X-rays coming into the detector. So the only other conclusion I could have is that there is some kind of gravitational effect going on. Wow. Okay, so hopefully you guys can now see why this was important. Actually, later on in this talk about Adamenko and in the Proton 21 labs, which he reported, I think, in an interview in 2006 or 2007. This slide here, where he actually found these things which, when he fired primary ions in, they disappeared. And when he turned the photomultiplier off, he saw this exponential decay of light, and then it disappeared. And then the lab technicians found that there was regular arrays of similar structures, but seemingly smaller, or the big one in the middle, and an array semi-regularly around this slightly irregular outside, where the same kind of thing occurred. So this was part of the pattern of data that was telling me that maybe there was some gravitational effect going on. And this paper here is kind of explaining the same sort of thing, that you get emission spectra changing because of gravitational effects. And for some reason, this alignment of gravitational bodies also show an apparent change in spectral lines. So I'm actually going to propose right here and now in this video that the next time there is a solar eclipse, that anyone in the vicinity of the area that passes over during the days at which the alignments or lunar eclipse or solar eclipse, in and around the days of which the bodies are largely in alignment, that they get a range of samples under an SEM and have it constantly monitoring what the so-called X-ray energy is that's coming back. something is going on that's allowing these kind of effects to occur, which we're seeing here. And I believe that it is something related to something like a gravity-like effect. And so, and this is part of the basis for my understanding of that. Now, the other thing, which we'll look into, is the research of abnormal effect of eclipse on the rate of atomic clocks. So he's saying we have analyzed atomic clock time comparison from ground wave data of 16 lock chain recorded from 1987 to 1993 by the US Naval Astronomical Observatory, and found an obvious impact of the solar and lunar eclipse on the data. So they've got various eclipses here, and they're showing that, you know, when you have the alignment here, you get a minimum. When you get the alignment, you've got a maximum. Here we've got a maximum. Here we've got an alignment with pretty much a minimum. Here you've got a maximum, and here you've got a minimum. So it could be that other celestial bodies like Venus or whatever, there could be some other effects that cause more of this to occur, and I would imagine that would be the case. But just focusing on the eclipse data, you can see that there are minimum and maximum there according to their analysis of the data. They then went on to look at other clocks in their own possession. So figure 9 demonstrates the results of a direct comparison between two cesium, this is cesium-137, which is a beta emitter clocks positioned in different azimuths, but in the same laboratory. A direct comparison between two rubidium clocks, which is the isotope that they use, is a beta emitter in the same laboratory in the city of Changchun, is demonstrated in figure 10. Analysis of the graph shows that the relative change of time difference between the two rubidium clocks reaches 3.6 times 10 to the minus 8 magnitude during the solar eclipse. The effect occurs not only on the day of the solar eclipse, but during the period of the three-body alignment approximately. So here's for your cesium, cesium-137, I think it's rubidium-87, I can't remember. But here you've got an effect during the eclipse or whatever. I think maybe one of these is the eclipse. And then the other ones, I think that's actually the eclipse. And then these are other events during the rest of the days. So here's your days, and these are the other days of the three-body alignment. So, of course, if we actually look here at his discussion, during the period of the three-body alignment, an unusual force of horizontal oscillation takes place. This period has various effects upon the grain arrangement of lead-tin alloy, upon the spectral wavelengths of atoms or molecules, and upon the speed rate of atomic clocks. The uncertain mechanism contained in these effects is not yet explained. All of the abnormal physical phenomena tell us in different ways that there are many secrets yet undiscovered, which occurring during the period of three-body alignment and which require further explanation. The most important work at present is to repeat our experiments and tests. So, what can we conclude from this? Well, I think you're going to find a lot more supporting data in here. But at the time of this publishing in 1999, Xu Wenzhou did not know what was causing these things, just that it was coincident with three-body alignment. What Alexander Parkhomov is suggesting here, and is a fact, is that gravity can manipulate what are now understood to be small mass, but do have mass, neutrinos. And he specifically says that the neutrinos from relic neutrinos can be manipulated. These are ones that are traveling much, much slower than the neutrinos that come from the sun, that are at much, much higher energies. He's also saying in his recent papers that electron interactions at temperature can cause the production of neutrinos. Now, what this could tell you, I mean, there's all kinds of interesting things can come out of this. And I want you to think about this. Could it be that, when they're doing these pendulum tests, the effect on the pendulum is different depending on the longitude and latitude on the Earth? and gravitational body alignment. You know, you've got crystal changes here. You've got beta decay changes. Could it be that some people have been unable to replicate biological transmutations? And if you look at one of the previous videos I showed you where they did things on the different phases of the moon, and they saw some transmutation on certain phases of the moon and not on others. So we have a body of evidence here that shows that low energy nuclear reactions could be very dependent on gravitational effects, and also could be affected by for some reason in Alexander Parkhomov's work, the beta emission output, or it changes most. It has a maximum during the January, February, March, and I think it's January, February, I think 1, 2, 3 in the year, and then it has a minimum in July, August, September. So, you know, if you're going to do lunar experiments, perhaps you should be attempting them during the first 3 months of the year. And I am actually kind of reminded of the fact that Alexander Parkhomov does like to do his experiments over the turn of the year. It could be that that could explain some more of his success. What he's now saying is that when you have interaction of matter, the electrons, and the body of the bulk material is over 2000 degrees Kelvin, that the interaction of electrons can form neutrinos and antineutrinos, which are ultra low energy, and that these have a wave function that spreads over as much as, I think, 5 nanometers or whatever. It's all in his previous paper. And so he's effectively creating these similar neutrinos to the cosmogenic neutrinos, but actually in situ in the reactor. Okay, what I'm suggesting is that it would appear that you know, even crystallographic changes. So
reset.
Dense matter scientists working with palladium or plasma or surface plasma, both, you know, whatever's created by electrical discharge or heating and cooling cycles, or because there's some hotter areas because of anharmonic oscillations, the recrystallization during periods of different gravitational exposure, which is, according to Alexander Parkhomov, causing fluxes of relic neutrinos, could result in some experiments producing higher levels of output. I think we're at the beginning of a complete demystification of LENR. I would like people to consider that potentially what we saw in this line reactor, as I felt I was seeing at the beginning of last year, that there is something going on that is causing these light effects, which looked pretty anomalous to me, and these effects under the SEM. In this case, where this is actually at the same, pretty much the same angle as all of the rest of this isn't some incident angle effect, and you're still seeing these supposed transmuted elements. You know, it could be that LENR researchers have done a best guess of what the element is there, but it's not that there actually is a change in the element. It's that there is some other exotic vacuum structure that's sitting within that metal, because Shoulders said these structures like to stay in metals indefinitely. That's sitting in that metal that is able to bend or accelerate light depending on or not necessarily just light, but it's affecting something depending on the instant angle. So I really encourage you to go through all this. And before I close out this video, I want to talk about, you could say, these are ridiculous claims. These are ridiculous claims. it is nearly the 30th anniversary of Pons and Fleischmann's announcement. And so I kind of want to bring it back to another thing that I was talking about. During the Magneto-Toro electrical radiation talk that I translated of Alexander Shishkin, I noticed that he was talking about this work by the Nobel Prize laureate Barkla from the 1910s, where he had discovered these over 100 keV emissions, which were more energetic, and they call them J radiation than K-shell emissions. And around that time, I discovered, when I was making this presentation, that Martin Fleischmann and other researchers in the early days of LENR also energy emission X-rays. And so you can go and look at this new type of penetrating radiation, Alexander Shishkin video for that. But I found this discussion in a interview that was published on Infinite Energy. And I said, really, I think people need to go and look at other things that are in this interview that was being said by Martin Fleischmann. Now, I'm going to tell you what I was referring to then. This. So here we are. This is page 1 of the November 1996 issue of Infinite Energy. And this is the interview with Professor Martin Fleischmann, conducted by Christopher P. Tinsley. And this is the section I want you to look at. Are you interested in any other, shall we say, controversial areas of science? Are there any things which most people would perhaps dismiss, but perhaps you have a less certain view? And Martin responds, yes, well, cold fusion is part of a much wider area. And I have been really quite uncertain that our theory and understanding of condensed matter is at all satisfactory. However, I'm not interested in some of the more extreme ideas which have been put forward and which interest you, in the future of energy. So Tinsley says, I will say that some of this gravity modification stuff does, in fact, appear to have a theoretical basis, as well as some experimental evidence, ... Martin responds, well, if you think about gravitation, until we have a unified field theory, then you can't be sure what's going to happen. Tinsley says, even Frank Close said that we don't know much about gravity and anything might happen. Martin says, we really have an incomplete understanding. This will change, but there are one or two notable exceptions, which I don't want to talk about now. We have no understanding of quantum gravity, and until that happens, we can't be sure that nature won't play some rather strange tricks. As I told you, when we were talking before, we had about four projects which we were working towards. One was to do with gravitation. One was actually to do with the behavior of electrons in metals. We actually started to collect equipment together to investigate the behavior of electrons in metals, but ... I have told you, and it's like, what was going on in here? Because this is Martin talking. I've told you, there have been certain themes which have run through my work, although they have never really been disclosed. I have often worked on topics where something short of the final answer would nevertheless be quite interesting. When I think about what I have done, I find that I have failed to achieve any of my longer-term objectives. Tinsley says, a pretty impressive failure, surely? Martin says, I have been content with what I have achieved, but I have not achieved what I wanted to achieve. Tinsley says, which was? Fleischmann, to gain a better understanding of condensed matter. In order to do so, as with cold fusion story, I find the answers to the global questions have eluded me. Tinsley says, most of the truly exciting science over the last half century has been in condensed matter. You are saying? Yes. In terms of its value to humanity, it has been the area of science which has been of the greatest benefit. And then he says, however, there is a lot to be said for working in high vacuum. Curiously enough, I am again extremely interested in the behavior of thermionic diodes. I find I do not understand how a thermionic diode behaves. As I am interested in the interaction of charges in electrolytes, I think about simpler systems, and from that try to understand the behavior of the thermionic diode. I do not understand it, and I don't think that anybody else understands electrons in a vacuum either. This is absolute dynamite. Please read it. Think over what it's saying again. Talking about electrons' behaviors in metals, about thermionic diodes. Read what they are. Look at history of thermionic diodes. Where does that start? Look at the fact that he's saying, I did work on gravitation. And there's at least two other areas here. There's areas which he did not disclose. What else was he working on? Well, we already know from our experience with John Hutchison that he was able to lift at one point with 4 kilowatts. He was able to lift 750 kilos, like approximately 1,500 pounds of metal in one go. There are videos of him lifting a cannonball and so forth. We know that he was able to disrupt metals. And we know from this particular video presentation earlier in there, we're able to see that there is the ability to affect crystal grain, to actually affect the way the material behaves. Now, if you can imagine something was cycling or having waves of, let's say, for argument's sake, gravitational waves coming through, you'd be going from something that's trying to be this to this, and it would just kind of jiggle around. Okay? Now, it's very interesting to me. Over the last couple of months, several patents have been released by the US Navy. One is piezoelectricity-induced room temperature superconductor. And this is using aluminium with PZT. So the aluminium is the most affected material, it would seem, in John Hutchison's work. And it's interesting that that is the choice here. I think it's an excellent LENR fuel for reasons I've discussed previously. So this is talking about room temperature superconducting. But this is connected to another patent. And that patent is talking about inertial mass reduction device. And here we go. And it goes into it. You can look at it. I'll have these links to these patent applications in the description. The other one is this. And this is about here it is, high frequency gravitational wave generator. Okay. And if we go through this phenomenon known as the Gerstenstein effect and can be utilized for a variety of applications ranging from advanced field propulsion. So we've got one of these related patents that's talking about gravitational shielding. So this is space drive, to communication through solid objects, as well as asteroid planetoid disruption. So like something, say, the size of Pluto. I mean, why stop at Pluto? But anyway, they're saying asteroid or planetoid disruption and disintegration when coupled with high energy electromagnetic field fluctuations. Here we go. We've got something that is able to destroy a reactor if it is the same thing that's going on. Down here is talking about craft mass reduction effects by quantum control and coherence of the collective quantum fluctuations in the vacuum and so forth. So these are very interesting patents. And these kind of chime to the superconductivity, the low energy nuclear reactions, the energy production that you would get from having a room temperature, the potential for energy production systems from room temperature superconductor, and inertial mass confinement. This is gravity. These kind of all the sort of concepts that are being discussed, maybe potentially by Martin Fleischmann. And we already from Alexander Parkhomov and others that it would seem that something is being caused by gravitational lensing of something that is able to transmute matter or accelerate decays. And for me, I want to drop in one little tidbit at the end of this presentation. I really want you to go away and think about it. When I was with John Hutchison, he said, my technology accelerates time. I want you to think about what that's actually saying. What does accelerating time mean? Don't take it literally necessarily. Think of the implications. Thank you for your time, and I really hope that you can pitch in and help out with the translation of this book. I think it's going to be a really exciting time this year in lunar history.
Elon Musk, great to see you. How are you?
Good, how are you?
I mean, we're here at the Texas Gigafactory the day before this thing opens. It's been pretty crazy out there. Thank you so much for making time.
Hey, welcome.
Busy day.
Oh, I'm sorry, guys. That was just an automatic.
No
going to
worries.
The next video.
Autoplay. How are you, Mark?
What's up, Bernie? Man, Bernie, are you freezing anything right now?
I'm
Stick
about
something
to
in
put
the freezer.
stuff
Make
in.
some.
I'm about to put some actual monatomic silver in the freezer, as well as set up start monoatomic silver on silver making as this eclipse.
We're pouring bismuth right now into a hot mold. So we're going to try to keep it above melting temperature for as long as possible. Oh, there it goes. It just went over a little bit. I'm trying to keep it above melting temperature for as long as possible so that we can, get the crystal growth going as long as possible here. I also have the nickel lead alloy that he talked about. We had a little problem earlier. As we were pouring it, notice that there was, because we heated up the, we heated this mold up before, so the
metal was interacting with the mold then, sort of. It was forming an alloy.
No, we didn't clean the mold. There were gaps in the mold. Tom, can you break these? You could just do it by hand, just twist them and crack them or something. If there's any pieces that are small, you can do it right here.
Well, you get, there we go. Yeah, I'm sorry. I'm just setting up my experiment here, so I'll put it on the big screen in a couple minutes. So, is Jeremy still there?
Yeah, I'm still here. My I don't know
Nice.
if you can see me.
Oh, I got you. Your shadow. There we go.
Yeah.
How's the weather over there? Are you able to see the moon currently?
Yeah, I can see it right now. It's a little cloudy though. It's overcast, but I can see like a silhouette of the moon with the full eclipse in swing.
Nice. I'm gonna run outside my house. The sun's just setting here in Alberta, so it's getting dusk, but it should be in the perfect spot for me to put my telescope out. So I'm gonna go check on that here. If you give me a couple minutes, and also I'll set up the silver on silver reaction. As I'll share a couple pictures first of past instances I noticed when making this monoatomic silver with a pure silver cathode, pure silver anode, and one time when there was a full supermoon, I noticed that it exponentially increased the amount of the monoatomic silver that it made, and the ancient alchemists claimed that silver metal is attached to the moon as a heavenly body. So it's quite fascinating. So I'm going to see if we can get some more evidence that silver actually is affected by the moon.
Mark, I'd be wearing safety glasses for that. I don't know.
Yeah, that's a great idea, actually.
Yeah, man. You never know when something could like just pop or explode when you're heating stuff up super hot like that. So
You are 100% right. We got the safety glasses on.
Good. Yeah. Set a good
Yeah.
example for these kids, man. We can't have people will try this at home.
We got bismuth right now. It's slowly inside this heated mold. I was heating it up with the 2 torches before, so it would cool down as slow as possible, so we could get some of that alignment effect in there. We're not at totality yet, so these are mid-stage experiments. We're figuring out all the tweaks in the experiment, make sure we're not spilling lead onto the floor like we did earlier. We're getting there. We have to really clean it very well in between passes, and the mold itself is at like 300 degrees centigrade right now. It's super hot, so I'm using these all leather gloves to.
Man, I'd have an apron. I'd have an apron or a lab coat or something on.
The aprons are a little. I mean, my jeans are fine against lead and bismuth aren't that hot of a metal. But,
yeah, they'll probably harden up by the time, like if you get lead solder on your jeans or something, it just turns solid. It won't burn a hole or light you on fire. Or anything.
Yeah, there's usually not enough mass there to create a serious burn. If you had like gold or iron, I mean, those are very high temperatures. That you're gonna have a serious problem. Are you saying you're able to see the moon now?
Yeah, I can see the moon.
Okay, I'm going to give you guys a view of the spectrograph right now. Let's see what this is looking like. Okay, we can see those spectral lines right now. They're coming into effect. There we go. So we're going to compare that with footage from earlier in the stream, and we can actually do the analysis afterward to see what sort of changes we saw. And this is just a standard spectroscope that you find on Amazon. Just giving you guys a view of our LED lights, but the concept is true for any spectrograph. If you have a prism right now and you're looking at spectral lines, you're going to expect to see a change in 2 orders of magnitude on those spectral lines, which is amazing. This is the lead tin alloy that fell before. We're going to stick it back inside.
Nice.
Oh, wow. Okay. Does anyone have a good view of the eclipse on the East Coast? I think it was 11:03, and it's hardened by 11:08. Yeah, that's hard. That's bismuth too. We're just lining up the samples on the side of the desk over here as we pour them. And the real science is when we do the analysis after. Right now, we're gathering the science.
What was the first one?
This was lead tin alloy. Okay, I'm going to pull this out right now. I think we'll wait. Until I could feel the heat. Through the gloves, I could feel the heat. Whoa, wow, it's hot. Ooh la la. Hot, 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 hot. There's the sample. Oh, the crystals do look a bit different. We're going to have to chop these up and probably brush them out or something like to really get the to see the full effect of it. Okay, in here we have the lead tin alloy is heating up. This is all different kinds of metals. I don't even want to bother mixing that with anything. So I don't know what it is. And this is definitely lead tin alloy. That looks like bismuth. Jeremy, did Bob Greener tune in yet? I know he sent an email earlier, so he is awake. I think Jeremy's there.
He commented in the live chat right before the stream started, saying that he had to go to sleep as it was 3:45 in the morning, but wished us luck.
I don't know if he'll be making it. We played his clip, which was key. That was really good stuff, man. He probably couldn't have topped that, done much better than that. I don't know. Maybe he could. He could probably add a couple things, maybe. But we'll see what he says tomorrow. I'd like to see if he did any experiments and see what he comes back with. Anybody else out there from the audience trying?
He's in.
Anyone freeze any ice cubes?
Yeah, throw some water in the freezer. Easy experiment. Yep, freeze some ice cubes. Tall. Make them tall. Try to get the effect.
Hell yeah.
Oh, okay.
So what I'm sharing right here is past experiments I had of making monoatomic silver through electrolysis with silver. This is the silver anode side. It's a 99.99% silver Canadian maple. And you can see if on the far right how it's a big cloud of monoatomic silver coming off of the coin, and then in the middle the oxide or silver oxide blue starting to form and eat up the cloud of the monoatomic, and then on the far left there's barely no monoatomic, just the diatomic silver oxide in the reaction. And it's I found it was correlated to the waxing and waning of the moon, and when it's a full moon it's making a big cloud of the pure white single atom monoatomic. And the far left picture here where it's producing none at all, just some of the oxidized silver oxide particles, was when it was completely waned or waxed out where you could not see it at all, see the moon. So yeah, I'm gonna set up the experiment to make more again right now as the eclipse is going on, and see if it cuts out or if the rate has any noticeable change from the rate it was yesterday that I was making during the Apex stream, as well as before and after the eclipse tonight.
Nice. Yeah, man, this is like just shows how little we know about quantum gravity and the effects of these planetary bodies and the kind of interferences and interferometry patterns that they could be causing in the quantum gravity structure, which would affect things like crystal growth and molecular biology and other things.
right? Because it's like realistically, they are the largest masses, the largest physical forces in our physical like existence, universe, solar system that are forces acting upon each other. So it would make sense that they do have much more like impact physically than what we are aware of. For instance, especially men don't really think about it, where women, it literally is their monthly cycle is tied to the cycle of the moon. And it's like the just like the tides are with the cycle of the moon, the woman's reproductive cycle is also in the sides.
It's called the menstrual cycle.
Yes.
But yeah, we get what you're saying. Totally.
Like that it physically affects human biological life to that extent. There has to be much more to it just than just the woo woo astrology sort of things that it's devolved into, compared to real science that the ancients seem to have figured out and know a lot more about than what we pay attention to today.
Yes. Get ready for the hyper periods because of the eclipse. Oh, jeez. Oh, Isaac Newton was super into all this stuff. If you read his, a lot of his original literature, totally. Yeah. Newton was totally into this stuff, which is cool.
Right, and
He
that's
was no
actually
dummy.
where Isaac Newton's alchemy writings is where I what got me into studying alchemy, and most of my discoveries are off of reproducing different alchemical descriptions of Isaac Newton's in his recently declassified and released alchemy, and it was alchemy and not religious, dogmatic, maybe it was called, or something, writings. But it just insane amount of information in there that's been suppressed and hidden for a couple of centuries. Yet Isaac Newton is basically the foundation of modern physics and science. So there's got to be a lot more realistic and relative information and discoveries in these alchemical writings of his.
Mark, how's it going over there with the bismuth smelt? Sweet. Yeah, people are doing the ice cube experiments themselves. That's a quick, easy one, you know. Some crystals in your freezer. See if nice. Heck, why not? Oh yeah, we're at peak eclipse, man. There's just a little tiny sliver of that moon left. Oh, that's cool. That is cool as heck. We got 7 minutes left till full eclipse. It's damn close now. Just a tiny sliver of that moon left. Heck yeah, that's cool, man. I'm just going to throw this link out here for people. Yeah. Oh, dang, it's getting close. That is so cool. Like half the moon's like dark, but it's red. It's like red, so it's like lit up. Oh, it looks so awesome. Just with the naked eye. I wish I had a telescope to look at it. I bet you everyone's outside looking at the moon right now, just checking it out. What should happen is in your ice cube trays is that due to the microgravity being, essentially shut out to the main planetary alignments, you should get more uniform crystal growth. Slightly. See how strong the effect is. If it's measurable, if it's serious, then we'll know something's up with that. Oh wow, it's almost peak eclipse. Yeah, I feel bad for the people that just have clouds. Man, all the clouds are cleared up now. I got a clear view of that. Again, you can barely see anything now. It's just a tiny little light. It's just a tiny, yeah, you can't see nothing. I'm gonna see if I can. Yeah, it's raining where you are. It sucks. Let's see if I can't take a picture of this. I couldn't quite get a good picture of it before, but
yeah, I just checked, and it's not visible from the horizon from my property, but I'm just going to go up the street here and see if there's a spot, and then I can put it through my telescope. We got some decent pics last night of the moon, if you saw that video. There wouldn't be copyright to most YouTube channels, like private ones, doing streams of the eclipse to share one of those in the meantime. Like not like if you play a NASA one or something, like you don't get strikes against it, right?
I don't know.
Especially, I think if it's muted, for sure, it shouldn't be an issue. I just saw a couple pop up on my YouTube feed was all.
Oops. Let me see if I can zoom in on that moon. It's really hard to see. Yeah, it's not coming out. It's starting actually to get a little hazy in the clouds. I can barely see like this red glow of the silhouette of the moon now. It's almost completely blacked out. How's everyone's crystals going? Anyone freezing ice cubes in the freezer?
This was yesterday. Hopefully, I can get the moon here in the next 15, 20.
Sweet. Yeah. Thank you for the $10 super chat, Frap Sap. He says his ice cube tray is growing tremendous crystalline fractal tessellations. Awesome experiment you have us conducting tonight. Sweet. Yeah. I'm glad that we can, that everyone's taking part out there for science and on board doing their own little experiments for science. Make sure you take pictures and if you can, and post your results. You know, let's come up with a hashtag so we can track all the results if people are posting pictures of their experiments. So if you post pictures of your experiments with your results, let's do hashtag
Lunar crystals.
Lunar crystal.
Okay, we're like totally clouded out here in Hawthorne, but I've been seeing pictures down south of us. They're getting near, perfect skies down there. So lucky them, but we're gonna continue running some experiments here.
Yeah, that's what we'll do, man. Oh yeah, thanks for the podcast. My dad actually, someone sent my dad they sent in that podcast, and my dad's like, dude, if you ever did this in any other country, you'd be dead. They'd come after you and kill you for like what you're doing, and he said they might still even come catch you. Like, well, clouds covering the Boston skies. Oh, dang. Yeah, it looks pretty cloudy up north of here. I'm down in close to Rhode Island.
Do you just like find some empty field or something?
Yeah, I wanted to pick a good open spot with a clear view of the sky. I was trying to get on the roof of one of these buildings, but I couldn't get roof access.
I should really be wearing safety goggles. There we are. Thank you.
Moon crystals. Hashtag moon crystals. That would be good too. Yeah. So lunar crystals or moon crystals. I'm going to look for both those hashtags. Baby moon crystals. Lunar crystals.
You should be entering totality right now.
Oh yeah, it looks pretty pretty total eclipse. Looks like full total eclipse right now. Oh yeah, it's the moon's like just red, blacked out. Oh my god, I just saw like a UFO right next to the moon. It disappeared though. I don't know if that was my eyes playing tricks on me, but or what. But. Come back. Take me to your leader. Right, somewhere there's a junkie cooking up some crystal meth right now, like, holy shit. That's what someone's.
Okay, getting ready for another pour here.
Yes. Peak eclipse pour. Make sure you label that one.
Lead tin, yeah.
We went over this already about why during the eclipse. It's because the alignment. It's the Earth's casting a shadow on the moon right now, which means that the Earth, the moon, and the sun are all lined up in a line. So those are the sun and the moon are the two main sources of gravity on the Earth. So they're going to be the two driving functions in the microgravity interference pattern that would be caused or cast on the your crystal. So it's minuscule, but it might be noticeable, and that's what we're trying to test tonight with our experiments. So it doesn't matter what you think or why would it or how much would it according to your calculations or this or that. You know, all it really matters is if we do some experiments and we get some interesting results, you know.
And this is an experiment everyone can do at home. You don't need to be melting metal. Any crystal growth should have this effect, including water.
Stick some water in the freezer. That was a great idea from Kermit.
Throw some food dye in it if you want. Something fun. Try it out.
Still metal. Still molten here. Still molten. Is there any view out there yet? What?
Yes. Would now be a good time to decalcify your pineal gland with some of those binaural beat frequencies?
How would you measure that?
No, there's no way to measure it, but just
Stop drinking the tap water, guys. It's full of fluoride.
that's it, man. You're crystallizing your brain. Grow those crystals in microgravity during the eclipse. Oh, geez. Anybody have any other interesting results? We got one guy gave us a $10 super chat, said that, you know, he was seeing some interesting crystal growth with his freezer experiment.
Still molten. We warmed up the casting pod over here so that it's very close to the melting temperature of the lead tin alloy. So this way we're going to have crystal growth for a longer period of time. It'll be able to suck in that alignment effect and hopefully give us some really massive crystals. We'll see the effect. That's with lead tin alloy. This is bismuth, and bismuth has some really interesting crystals. That's just from a regular.
That's super cool.
Wow.
Yeah, some super cool bismuth, but that's not that.
That's your control sample. That's not the eclipse, right?
Yeah, that's not the eclipse yet. The eclipse sample is actually over here, and it's in this little puck. So we're going to have to break this apart in order to see the crystalline structures. We're going to do that at a later stage. Probably not tonight, but we're gonna eventually do that and do a comparison, side by side comparison.
Yeah, Simon just got here. We showed a presentation by Bob Greenier talking about some of this stuff, and he was citing a number of scientists like Martin Fleischmann and also Isaac Newton, who are into a lot of these, you know, planetary alignment experiments, and thought that there was something a little bit more to them than you know, regular other scientists seem to think that there's nothing to this. So this is what we try to do, is we test weird fringe kind of science stuff on this channel. So heck, we're having a mass science fest to have a bunch of different people try some experiments simultaneously underneath this amazing eclipse. There ain't going to be another one like this in our lifetimes. I'll tell you that.
Not with a live stream from alien scientists and all the experiments going on.
I wish I had a picture of the eclipse.
Maybe somebody can pop it on. Bernie, can you stick your second camera on a picture of the eclipse? Give us some live footage there. Maybe when Bernie will be able to handle that.
Yes, I can. I'll see if there's another YouTube channel streaming it that has the.
NASA has a live stream right now. Use the NASA one. It's pretty good.
Yeah, I'm pretty sure we can use the NASA, and as long as it's muted and then like we're talking over it, there shouldn't be any copyright issues.
Okay, guys, this is our spectral analysis. Let's look at the spectrum through the spectrograph. Some light there. There we go. There you can see the spectral lines, and we're going to compare that of before and during and after the eclipse. Have an idea of what in the world is going on with the spectral lines. Well, you see that really strong line right by the on the ultraviolet end of the spectrum, towards the purple. It's pretty strong there. We haven't seen that before. That's another effect that is expected from a three-body alignment, such as what's happening today. No, it's not even solid yet. It is not solid yet. No. Oh, this is going to take a while. Part of the sky that's cloudy is where the moon is right now. So hopefully we'll get to that in a moment. Still molten.
Yo. What's going on?
Hey, Mike, how are you, brother?
Oh, good. Just working on these graphite batteries. Got
Nice.
some more, yeah. Here, I'll do a little demo here. Pretty bright, eh? Yeah. We got 1, 2, 3, 4, 5, 6, 7 cells going. So I got quite a bit of power here. So what's going on?
Not a whole lot. Oh, that's cool. That's a nice, nice view of that eclipse, man.
Oh yeah, it's the blood red moon tonight.
Happening right now. How's the weather in Toronto, Mike? Is it clear sky? Can you see the moon from your apartment?
It's a little cloudy here. We got rain coming in, and we had a pretty hot day. It hit 30 with the humidex.
Whoa.
Yeah.
That's pretty hot for Toronto and me.
No, it gets a lot hotter here It could get up to 36, 38 sometimes. Yeah, but for May, yeah, it's not bad. It was 27, and then with the humidex, like 30. So yeah, it was about 85 degrees. At least there was a bit of a wind, so it wasn't too bad. Enough to get a suntan.
No doubt.
Yeah, so these
Almost.
graphite batteries are working out pretty good, man. So I'm working on a design. There was a guy out in Singapore. He made like it looked like a car battery, but it was all made of cardboard. And he's selling it for $235 US. It's like an emergency power cell. Then I looked at the specs of it. It's only putting out 5 volts at like 20 milliamps. And you're paying $235 US for it. I made this for like $60, and I'm getting like almost 10 volts out of it, 9 volts and change, and like, you know, you can see like look how much power I got.
And that, like, you run those batteries pretty much all night, and it keeps the light going, right? And then you just need to refresh
8
it with
hours. They'll run for like 8 hours, and then I just hit them with a little bit of water, and boom, they just come back to life. Now, 4 of these cells are over 2 months old, so they're holding it. They're lasting. And even if you have to rewrap them with new magnesium, you know, a couple hours, and you got brand new cells. So I did 3 brand new ones tonight, and I still have another 2 more to do. Yeah, I did 3, and I got to do 2 more. So I should be topping out over 12 volts, 15 volts. So yeah, it's not bad. Yeah. So I'm going to be redesigning the pulse motor, and going to be working on the atoms motor type setup. So I'll be doing a.
I saw your video on that. Do you want to describe it a little bit more? And just for reference, because we're live on Jeremy Alien Scientist's channel, not mine right now. So
okay.
You do a general explanation, as there, nobody really knows the backstory. And you've done a Don Smith generator, a pulse motor, a Jared Morin generator, as well as the N machine, right? And
yeah,
then,
those are all the devices that I made that actually worked. You know, like I try to build these projects to see if there's actually some, you know, truth, you know, behind the myth kind of thing, if they actually do work. So all of them do work. The Don Smith generator, that one there, like I said before in my last shows, that, you know, you're opening up a can of worms. You're dealing with high voltage static electricity, and you have to basically change it completely into a usable form of power, which is not an easy thing to do. So that project there is, you know, I'll be continuing to work on that. It is not easy. So if anybody wants to get into it, be prepared for a long ride. Let's see. The N machine does work, but the research that I've covered on it, especially from Eric Dollard, who actually knew him personally, that machine was not over Unity. So in order to get over Unity with that device, the machine has to be enormous, totally enormous, in order to get the power you want out of it. His machine was like over 1,000 pounds of magnets. So I made a miniature version of it, you know, like really small. And yeah, I'm getting current out of it, but nothing that's actually usable. So that one's kind of on the sideline. I did a lot of research on that, did a lot of development on that concept. But yeah, until you can get that generator to do pulsing power, like an AC type thing, right? which I know Peter Linderman and Michael Knox did that back in the late 80s. They were actually able to make it almost like an alternating current, and they got some pretty interesting results with that. But Bruce De Palma, it was not over Unity. And that machine actually wasn't originally designed by them. The original machine was called the Starburst machine. So, it was kind of funny today. There's a guy out there, he calls himself Master Evo, and he does a lot of Tesla stuff. And I looked at one of his circuit diagrams in his video, and it turned out it was exactly the same kind of setup I had with my Don Smith. Now, here's where the alien scientist guys might be interested in. He hooked up a copper plate with the electrodes coming off the electrostatic discharge, and he was able to get deflection. So he was actually able to create field propulsion with the setup I have. So I might actually try to do something like that in the near future, see if I can get some kind of field effect and actually have like field propulsion with the Don Smith. So I looked over his schematic and it matched exactly what I'm doing. So yeah, he did a test, and sure enough, that plate started to wave back and forth. Not very much, but it was enough to actually see it moving around. So it was proving that there was, some field propulsion going on there. So
Mark,
that was
how far away are you from Toronto? If Mark's there. Sorry, I'm just asking because Mark at the lab probably has some good equipment to help you measure specific effects.
Well, you could actually see the actual effect. It starts swaying back and forth. When you hit it with the high voltage static discharge, it's causing a field deflection. So if it's pushing on the ether and it starts moving, that means there is something going on there. Whether it's, the Townsend Brown effect or whatever, But I found it kind of interesting when he showed the actual test that he did. It was actually moving quite a bit.
Hey, you see it?
Sorry, Mark, are you asking for Mike to give
Yeah, he goes by Master Evo. He does a lot of Tesla
your
stuff.
model of it, like your build. Do you mind?
I could get it out, but it would take a couple minutes to get it out. I got other stuff on the table here.
Do you want to show what you got on the table first?
Well, yeah, I just, I got the batteries, right?
Yeah, so Jeremiah has also done the build for some of these batteries and doing a test with them, as well as Kevin.
Oh yeah, they work. They totally.
Oh, for sure. I'm letting everyone know on this channel because it's not our channel of months of your work.
There's the cells there. So I built these guys today, and then I got the power coming off them, which is quite a bit. You could see it's a pretty intense light coming off it. It's about 9 volts I have coming off it right now. Now, when I was doing a test with each cell individually, I'm getting about 250 milliamps of current coming off it. So, yeah. So I'm just working on it. I'm coming up with some concepts and designs how I'm going to actually make the battery pack. All these cells are going to sit inside the battery pack. And then I'm going to
maybe have like a timed mister or something.
Well, that's exactly what I'm doing. I'm going to set up a misting chamber that's going to funnel that ultrasonic mist into the chamber where these cells are, and it just has to give it a shot once every 5 to 7 hours. Just give it a quick shot for about 10 seconds, and that's it. Batteries are fully charged again. But I hate using batteries because more and more I'm reading up on this. It's actually a reactor. because they're called graphite magnesium air battery. So you're getting the transfer of ions from the magnesium through the dielectric to the carbon graphite rod, and then comes out the top where the copper wire is inserted at the top. So it's not a battery because, I wouldn't really consider water really an electrolyte, but some people would beg to differ and say, yeah, it's an electrolyte. But can you charge a battery in about 3 seconds? Well, no, you can't. Well, with these, you can. They take all of about 3 seconds to basically come back to life again. So, yeah. So that's what I'm working on, and then eventually I'm going to get to the Adams motor. Robert Adams started his project back in 1967, and he developed the motor, he built it, and he was proceeding to get a patent on it. So he sent it to the patent office in the UK, and this is about 1975. So I was about 2 years old when he was doing this. So I was a baby Faraday. So he tried to get a patent on it, and apparently it got seized by the government. So he was denied the patent, told to never build the motor, and basically watch your ass. So he kind of went into hiding. He had a couple of incidents that could have resulted in his demise. So he went quiet for quite some time, and it was about 77 years old. It was around 1992, and he finally said, "You know what? I'm just going to release it. I'm going to put all my patent, everything out there, open source, so this technology can, be carried on by somebody else at another time." So because he knew he wasn't going to be able to get anywhere with it. So come to my time, about 4 years ago, I started building this pulse motor. So I was finding some interesting anomalies by using a mechanical switch over a MOSFET. I was able to create a lot better charging characteristics with my batteries. So basically, it's a negative charge. So when you get a new battery, you have to discharge that battery to almost zero. After you discharge it to zero, then what happens is now you start pulse charging it with the Adams motor using a negative energy going into it. So therefore, if you don't do this, eventually what will happen is you'll actually kill the battery. You'll destroy it. So you got to get the positive energy out, and then after you get all the power out of that lead acid battery, you start charging it with the pulse motor with a negative charge, and then that battery will live. It won't die off. There's two different charges, and that's what Linderman was finding out, and Bandini found out. He was killing batteries, and he was trying to figure out why. So they finally figured out it's this negative charge. So they started discharging their batteries first, and then charging them with a negative charge. And after that, they had no problems. They were lasting, and they were charging up way faster than a conventional battery charger. So, yeah, so basically that's what I'm up to, and it's a work in progress. I got the designs, what I want to do for the new motor. It's going to be scaled up. It's going to be putting out quite a bit more power. So, yeah, that's where I'm at.
Guys, the moon is about to occult a star, which is going to be a really cool thing to watch.
Yeah, it's pretty cool. Yeah, I've seen it before like this. It's a few years ago. They went blood red.
Yeah, the blood moons.
Yeah, the blood moon. We had a very good view of it. I think it was not last year, the year before. We had a really, really good view of it. Pretty creepy looking.
Do you mind doing that other setup that was requested?
Yeah, I could do it, but it might mess up with the electronics around.
Oh, all good. part of the show?
Now, I haven't done that deflection experiment yet. I haven't done that. But the actual setup is very easy.
Yeah, no, the people are very interested, and that's crazy. $200 for a battery, emergency battery that does 5 volts, and how?
Like, I think it's like 20 or 30 milliamps. It's nothing. And I'm putting out way more power. Like with these cells here, I was hitting well over an amp. So yeah. Yeah. Oh, sushi. Hold on a sec, guys. Hold on. Sorry about that. I almost had my chinchilla make a run for it.
Little furry critter.
Okay, just give me a few minutes here. I'll just put myself on mute and I'll try to change up my setup here.
Awesome, greatly appreciated.
Yeah, okay.
Mark, are you ready to show off some more of what you're working on? Mark? And is Jeremy still here? We've lost Jeremy and Mark. Oh dear. Well.
Get that piece out? Yeah, I got that piece out. Nice. So the next one is going to be bismuth.
Ah, there's Mark. Mark, do you mind? You got something to share for a minute?
Yeah. So we actually caught a break in the clouds and managed to watch the eclipse through our 100mm pair of binoculars outside, and it was pretty awesome. As that star was getting occulted by the moon, a cloud came in.
Always, right?
Yeah.
So I just need a couple more minutes here to set up my monoatomics, and I'll have it going and be able to share that as well.
Sweet. We're about to pour some bismuth. You go look at the telescope maps. Tom, use hand here. This is out of gas. Can you replace it with that can over there? I'm assuming that one's full, right? It's heavy. Yeah. Good. Tom, I need the note. The note. Note taking. Bismuth. We're gonna pour it. 12. What are you gonna pour? Right. I'm about to pour it. Okay, I'm gonna pour it now. We're near peak eclipse right now. Peak eclipse, I think, is. 1 second. Oh, safety glasses on. Just removing the slag. Pinky back. Bed.
Okay, Bernie, I'm back here. Okay, I got the Don Smith circuit here. If you guys want to see how I did it, I'm not going to run it, but I'll just show you it. Eventually, I might try the deflection experiment. You there, Bernie?
Yes, I am.
All right. So the circuit's actually very easy. It's not hard at all. It's basically just a disruptive discharge that's going to go into a copper plate. So I'll just go over the circuit really fast. So you're going to have your high voltage flyback transformer, and you're going to hook it up to a couple of 15 kilovolt capacitors right here. And then from there, it's going to go into your spark gap, okay? And then from the spark gap, you could either go through 1 or 2 spark gaps. You can actually try a couple experiments to see how it works. But if you're just going to do one, basically one end of the spark gap, you got the wire here that's going to attach to one side of the plate, all right? And then out of the other side of the plate, coming back to ground, will be the second wire. So it's going to go spark, make that disruptive discharge, hit the copper plate, create the deflection, and the grounding wire would be this on the return. So it's a very easy setup. Now, history of disruptive discharge was about 1/2 inch to 1 inch long. So it's going to be extremely loud when you do it. Like this one here can do 11 kVA. So it would be extremely loud, but he showed the effects were actually pretty good. It's on a Master Evo. That's his YouTube channel. And he just posted that video today. So it refers it to field propulsion. And it did work. So I thought that was quite interesting when he showed the actual circuit. They go, that looks familiar. So yeah, I might actually try that in the next little while.
Yeah, it's been that way though.
Any questions for Mike?
Is anybody home? What was that last comment somebody posted there? Yeah, it's basically like a spark gap transmitter. Yeah, because it's going just through. You're sending high voltage from your flyback. You send it through the spark gap. It creates a huge. Well, if you put it through a coil, it'll create an EMP. But But instead of doing that, he sends that high voltage to a copper plate on a wire, so it'll swing. And the return will be the second wire that goes to earth ground. So you're just sending that high voltage through that plate. And yeah, it works. Now, I don't recall the voltage he was using on his system, but I know mine could do 11 kVA. And I got a couple of 15 kVA ceramic capacitors at the front end, just right basically where the flyback comes in. Those capacitors get filled up. Now, he says the gap has to be quite large. So you're looking at a pretty loud machine. And might tick off your neighbors a little bit as their electronics goes a little funny. But it won't be too bad because it's not hooked up to a coil. But if it were hooked up to a coil, which I usually, when I work with this device, I have it hooked up to a coil. And I almost blew the display panel on my power supply one day. So half my numbers on my power supply don't work anymore because the MP hit it so hard. I'm surprised I didn't do more damage. So yeah, you got to be careful. And also the FCC and all the, here in Canada we call it CRTC. So I got to watch out that I don't violate the radio laws. So I try to keep it under control. So yeah.
Jeremy, if you could highlight me for a second, I got the spectral lines going on right now. Jeremy? Yeah, there we go. So this is another effect that we're supposed to see during a total eclipse, is that there should be a change in the spectral lines. If I can just get this aligned. We're at just about strongest eclipse right now. We got bismuth cooling inside of the container, inside the ingot holder, and it is hot, so that it will have a nice long cool time. So this is going to be like the penultimate sample right now of bismuth cooling at the peak of the lunar eclipse. Now, I'll give you a close-up of it. Right there, shaking it, you can see that it's still is liquid. It's still in its liquid phase. We did get a chance to peek at the eclipse a little earlier when the clouds moved out of the way. Jeremy, how's it down there by you? Maybe he stepped away.
Yeah, I don't know where Jeremy went. He's been missing for the last 15 minutes. I was just about to give him a call and see where he went, and hopefully he rejoins us shortly, as we are on his channel live. I did get this one is a gold silver monatomic electrolysis reaction set up and going. It's a gold cathode, a 10 gram, 24 karat gold cathode, and a 1 ounce, 99.999 silver maple anode. And
Bernie, for the record, where are you located?
I am in Calgary, Alberta, Canada. So
okay, latitude, longitude, roughly.
Sorry.
The latitude and longitude.
We are in mountain time zone, so it's one province or like one state over from the west coast, and it's like 100K to 150K from the U.S. border north. We're like,
yes, you're probably around like 60 degrees north or 55 degrees north, something like that.
Yeah, probably 55 to like 52, I'm guessing. Or what's the
I'm at
border?
43 over here, because we might see different effects based on our height and our latitude.
Absolutely.
Oh, it's getting close to cooling off here.
I'm going to just quickly move the camera here for a better view of the monatomic silver starting to form below the coin for all to see. And then I'm going to run out quickly and see if I can find the moon and then put it through my telescope.
He's back.
I'm back.
Okay, we're going to be opening up the bismuth cast right now. This was done near totality. Hopefully it's solidified enough. Ooh, that's a perfect cast right there. Really hot. Hot, hot, hot.
Mark, question. Are you using the exact same molds and methods for the crystallization?
Yes, we are.
For your control experiments?
Yes, we are. We didn't have the mold heated, though. So that is something we could always run another control experiment.
What do you have going in that flask, Bernie?
All right, so I have
What do you
set up
got?
with 5 volts. It's a 10 gram, 24 karat gold bar cathode and a 1 ounce, 99.999% silver maple coin anode in the reaction there that's bubbling. And then the monoatomic material swirling in the jar next to it was the same combination that I made from the reaction yesterday during the apex stream of the gold cathode and the silver anode.
Have you ever tried magnesium?
I a little bit, one little piece, one time, but it was when I was first doing it in a garage lab that I had, and I've since then kept away from the denser, even though that one's not that much denser, but just in general, I've stayed to the softest metals of gold, silver, copper, zinc, a little bit of aluminum and iron, just because as you get to these more complex elements, metals, you have a higher, and I talked to Bob Greenier specifically about this, who confirmed the suspicion of mine last week, is that you have a much higher chance and real actual radiation and what is nuclear decay of, and more nuclear reactive isotopes that will form from it, nuclear decay radiation, when you're using these denser, bigger, heavier elements in these processes, and thus there's a risk of that. So I've stayed away from it.
Yeah, I'm just finding magnesium's got a lot of reactive properties to it.
It was really cool when I made it. It was like a yellowy white, an off-white, the monatomic or the particles that were made when I did use the magnesium. And when I put that stuff in a jar, it literally moved around on its own, like up and down and all over, reacting in the sealed container for over 3 or 4 months. It was pretty intense stuff. The aluminum also, when it's in the monoatomic form, it will be reactive, moving on its own up and down, and like seems like it's charged. Where it separates, about 50% of the mass goes to the very top and 50% goes to the very bottom of the jars. And it will do that and stay like that for about 6 to 7 months after I've sealed it and taken all of disconnected the electricity and then sealed it in a contained jar. Jeremiah, hop on.
Actually, I got to head out for the night. It's already 12:30 in the morning here, so I got to be up at 7.
No worries. Thank you so much for sharing, Mike. And
put my 2 cents in.
I will post your YouTube link in the comments for everyone and anyone interested in what Mike's working on.
Yeah, so right now I'm just trying to get funds together. So I got the donate stuff there to try to raise some funds for the next project. So yeah, it's coming in, but a little slow, but it's going to take time. But it's going to take a while to get this stuff put together. So step by step.
Exactly, right. And Mark, if you're there quickly, Mike, before you leave, you guys should see if you can get some of your builds to Mark to specifically test with his high quality measuring equipment, I guess. Like, he's got the full lab.
You can't
there.
measure that.
It's not that you can't see it or like you're not noticing the effects yourself. It's that by then getting it verified with the equipment in a lab, it's able to
if it's anything electrically, he's going to blow up his meters. I wouldn't even attempt to do that. You'll fry it. When you're working with the high voltage spark discharges, you're just asking for trouble with your equipment. That's why it's very, very hard to.
A 1,000 to 1 voltage divider, good up to 100 kV.
Yeah, you could do that, but you got to worry about the electrostatic, the EMPs, because I've already blown up a couple of meters because of that. Frying the digital displays. Usually that's the first thing to go.
Need some analog equipment. Mark, do you have any of the LCR meters? Michael
I have
Boyd
one.
was talking to us about that.
Yeah, I got one on the way. I got one of my Patreon guys sending me an LCR meter this week, so I'll be doing some work with that. But anyways, Bernie, thanks a lot for having me on. I gotta check out here.
Jeremy. It's Jeremy's show.
Oh, thanks, Jeremy. Wherever he is.
I'm here, man. Thanks, Mike.
Hey. Yeah,
this is Mike from Faraday Research, guys. If people go check out your channel, tell people where they can find your channel and everything.
Yeah, it's just go on YouTube and type in the search Faraday Research, and you can type in pulse motor, you can type in Don Smith generator. I pretty much pop up.
I posted the link to his YouTube in the private chat if you want to share it, Jeremy. I can't post in the regular comments.
Mike, we have a room-sized Faraday cage over here where we're running EPR experiments or dynamic nuclear orientation.
Yeah.
Trying to orient the subatomic particles in the core of the atom. So if anything you got going on is related to that, or if you want us to put a sample inside that setup, we can do that. It's all set up right now.
Yeah, I'll get the schematic of the actual deflector that Master EVO was working with. It's basically the same thing I've got. And he showed the experiment, and there was definitely deflection going on. So he's been around for a while. He's probably one of the better guys out there for like back engineering Tesla. So, yeah.
Oh, look at that moon.
All right, guys. See you later.
Later, Mike.
Much
Take
love,
care.
Mike.
Take
Thanks
care.
for joining.
Bye.
Anybody else from the live chat got any crystal experiments of their own? I know when we started the stream 2 hours ago, we told people to put some ice cubes in the freezer and just check out how those crystals formed. Any interesting observations? Anything to note?
What I've just noticed, and I was like, why the heck isn't the experiment working? Well, it kind of proves my thesis, I guess, of how the monoatomic silver stopped producing when the moon was waxing and waned. So it would make sense that when it's eclipsed, it would also stop the production, and that is why we don't see any of the particles forming, I guess. I can load a comparison to yesterday's stream when I did the same process during APEC.
Yeah, you got to plant your root vegetables tonight, guys. Tonight's the night. Get them in the ground. Go plant your tubers and taro roots. Heck yeah. How much longer are we going to keep this going for? Because I'm like falling asleep, man. It's late here.
Another 10, 15 minutes, if that's all right. Now that I
another
have
15
this
minutes of totality. Let's keep it going until the end of totality, at least.
Yeah, and Jeremy, if you need to go to sleep, since you made me an admin on this, I can end it and whatnot, and keep it running if you with Mark.
Yeah, you'll be able to end it, right? I won't
Yeah.
have to come back on and end it. Yeah.
Yeah, 100%. I'm able to end it.
Sweet. All right. Yeah, I did see something when I was looking at the eclipse earlier tonight. I saw like a red. It was like it almost looked like an explosion or something in the sky. It was like a red blink and a bright, I don't know. It was like a bright red thing, like right next to the moon, but I only saw it for a second. And I don't know if it was like other light somewhere else. Maybe someone was shining a laser up or something from far away, or just like, I don't know, maybe my eyes were playing tricks on me, but
was it
just
like a flash sort of thing? And did it seem like it kind of shot off?
Check out those crystals right there.
I wasn't filming, but I did.
Because what you've described, I've seen through my telescope before when looking at Saturn. By one of the moons of Saturn, I saw like this little light. Then it like went across past Saturn to like where the other moons were, and like just another flash and disappeared.
It looked like a red aurora borealis or something. It was kind of weird.
Ooh, that's fascinating, actually.
I have no idea.
Just to explain
Probably go back on
the
the
reference here of the experiment that I'm doing. This middle jar from yesterday, all the white fluffy cloud stuff, that should be forming off of the silver anode that I have running right now. But it doesn't seem like there's anything forming in this jar compared to what had go yesterday. And the one in the left was monoatomic. Gold on gold reaction, and it produced, I think, crystal gold particles, as well as the very bottom. You can see that whitish, beigeish, also the monoatomic gold.
Okay, we're about to pour some bismuth now. I'm not going to reheat it this time. I want to have a quicker sample time. Get some of that slag out of the way. Okay. We are ready for a pour. This is bismuth, and it is 12:39. It's 12:42. Here we go. There's some samples. That's a cooler, a faster cool for the bismuth. Give a faster cool for the tin lead alloy.
Sorry, Mark, do you want to hold that up to the camera again? Just put you back to the big screen.
Let me do this pour first, then I'll gladly bring it over. Taking notes. Here we go.
Very nice. If you're able, if you have the extra bismuth, Mark, maybe do one more where you super cool it, like by putting it in water and see if there's a different effect that way.
Yeah, that's what I'm doing right now. I'm actually not heating up the mold between runs. Using water to cool down the I'm actually getting a lot more throughput of samples this way. You have me spotlighted right now? Here, why don't you spotlight me real quick? Oh, there we go. This is the lead tin alloy. Just came out of the cast mold. This was the cooling, the faster cooling one. Now we're gonna do a bismuth one with a colder mold. Okay, bismuth is ready to pour. It's 12:45. Okay, we have a leak in the crucible. This is gonna be a problem. Okay, I think the bismuth crucible is having some trouble there. Oh shit, we got some metal in there melted out. That crucible is dead. Were you able to see the eclipse, Bernie?
And it started, it wasn't above the horizon yet for me. And I haven't had a chance to run out again since, so I'm going to just quickly do that right now. So I'll be back in a couple minutes. I'll leave things running. Jeremiah, if you want to join, brother, I can send you the link.
I think we sent it to his email.
Well, if JP, if you're doing the same experiments, you should be doing it on camera with us. I know you just woke up, but you're beautiful either way. We don't care what you look like. Not saying you don't look amazing when you get out of bed. I'm gonna shut up now. Gonna go look at the moon.
Yeah, I think it's a good idea, Bernie. Okay, here we go. This is lead tin cold pour. There we go. There's another sample. I'm going to do a bismuth pour. Get a little heat on the top to It's got some really big crystals here.
Jeremiah, I emailed you the link if you care to join, brother.
We were going to get Bob Greener on, but it seems like he fell asleep, so we just got his.
Yeah, so Mark, Bob actually posted in the live chat of this stream right before it started and went live that he wished he could join, but it's 3:45 in the morning, so he had to go to sleep. He wished us luck and he'd check it in the morning.
Yeah, he was actually the inspiration for this. And I contacted him after his last APEC presentation and told him that we actually want to try that experiment that he mentioned and want to see if he can join us for a live stream. And he said maybe it depends on his sleep pattern, because it is pretty freaking early in the morning right now.
Yeah, he's just such an inspiration and amazing pioneer in so many of the fields of science that we are all working in. It just sucks that he's over in the UK, so the timing is hard for us in North America to make it work with him.
I think this is going to be the last. Okay, I think we're definitely cool by now. Oh, check that one out. Let's take a little break and show you spectral lines.
That's so freaking cool. So where I am in Calgary, Alberta, Canada, I cannot find the moon in the night sky for the life of me. So I don't know if it just hasn't risen yet, which is strange because I guess it changes what time of day it comes up each day, right? Does anybody know how much the moon alters its rate of rising on the horizon each day?
Trying to get the water out of there. It was cool enough for water. Okay, I think this is going to be the final pour of the night. We are exiting totality right now. And I am running out of lead tin too.
Can you guys hear that? It sounds like there was 10 gunshots. 2 more? 3 more?
I'm here.
2 more? I don't know if you guys were able to hear that, but as I'm walking down my street, it sounded like someone just got into a gunfight. Hooray.
Or maybe
Love
fire.
this world. Could have been, but it was weird in how there was bursts and pauses in between. So someone was saying it was just a sliver of the moon remaining right now, so where they were, so maybe where I am, the moon is fully eclipsed and that's why I can't see it. Because
No, everywhere on Earth sees the same thing. Whatever they're
I guess
seeing,
it just hasn't risen yet.
it should be low on the horizon from your latitude, like pretty low. Look south.
Yeah, because yesterday when I checked, it was already like a couple hours up off the horizon. So I thought it should have risen by now for me here.
Guys, here it is. Here's the science. These are the samples we cast. Let me go see what the spectral lines look like right now. I'm seeing that line in the purple there, it became a lot less pronounced than it was earlier. I think it's less pronounced. I don't know. We're gonna have to analyze this video afterward and compare the before and after for these spectral lines.
Jeremy, I fully agree with you. The WEF, like the corruption and the infiltration, is just insane. If anyone has seen the research and expose on it that came out a few weeks ago, and whatever the head's name of it is, the EU chief, or I guess World Economic Forum chief, but literally 2/3 of Trudeau's MPs were all WEF youth members, and how there is not an investigation or it not being criminal collusion of treason for all of these members of parliament, the majority of them in this party, to have all been part of this secret, essentially secret organization or economic organization. It blows my mind. Yeah, Mario Draghi, was it? Or Mario something. V, I couldn't agree more. For some of their war crimes, it's insanity. They're just plumbers, right, Jeremy? I can't find the moon in my sky for the life of me, so maybe it hasn't risen at my location yet. I blows my mind. There's a little bit of cloud cover, but I think I'd see it. And maybe it's behind those clouds. The biggest oxymoron, I think, in Canadian history is our current Deputy Prime Minister, Christina Freeland, where she is the exact opposite of free land. If things really were a democracy, they should be a law that any politician that sends military troops to engage in a conflict or war should automatically have any of their children or siblings of draft or military age be the first to volunteer and conscript into that specific conflict and front of the conflict war zone. But we all know that never happens.
All right, man. I'm probably gonna be out here soon. If you want to wrap it up soon, thank you everyone who participated and everyone who watched and stuff. I can't wait to do a analysis, a side by side comparison of all the experiments later, and we'll talk about some of that stuff. But yeah, I agree with a lot of this. Thank you guys. It's late here. Time to go to
Fair
bed.
enough. Just to quickly, before you end it here, Jeremy, to display, if anyone checks out my Apex stream yesterday, on half the screen I had the same silver gold experiment running for about 6 hours, and
Yep.
this one's been going for about half an hour, and you'll be able to see that it was producing a lot of stuff yesterday, and today it's literally produced zero during the time of this eclipse, which correlates exactly to my previous thesis of during the waxing and waning of the moon, it not producing any monoatomics.
Interesting. That's interesting. Yeah, pretty cool stuff. Again, yeah, share. Let's give a round of applause for everybody, and let's get some, yeah, clap, man, and let's get some data on. Remember, guys, everyone post your data, pictures, and everything, and use the hashtag lunar crystals or moon crystals, and we'll keep an eye out for those and check out these results.
Quickly to add in there on that same topic, I have a video from about 2 months ago on my channel where I produced it was monoatomic zinc and silver, about an inch of the white fluffy stuff at the bottom of the water of this container I put out. Below it was the supermoon, so maybe it was 2 or 3 months ago, and it was about minus 20 degrees Celsius in Calgary, Canada, where I was at the time. And the monoatomic matter formed into these crazy crystals. They almost look like quartz or diamond crystals out of the zinc, silver, white, fluffy matter at the bottom. And then through the video, I show myself harvesting, bringing it out, running it under warm water, so it wasn't ice. And it wasn't necessarily salt either, because it survived going through the water. And then about 2 hours later, they turned back into pure white powder, oxidized out and dried out into the same monoatomic material.
Oh, guys, Jeremy, don't forget Tuesday at 7 p.m. we have Congress talking about UFOs in an open session for the first time in over 50 years. We got to do a live stream to watch that and open commentary.
Absolutely, right? And first time in 50 years. It's like, was there the sunset clause that came up, and that's the real reason why they have to disclose and discuss it again.
Anyways, yeah. Tomorrow night's also Steve Ellswick on my channel talking about promoting Tesla Tech. So I'll see. We'll see you there.
Amazing.
I'm gonna shut it down. I'm gonna go to bed now, guys. Have a good night.
Much love and respect, brother.
Yeah,
Thanks,
are you still streaming on Crypto Alchemist if people want to stay watching?
No, I actually just joined on your channel. I didn't put it live on mine. We'll figure out how to do that on the next one to do the multi-streams. So yeah,
we'll just continue the experiments, and we'll do another one. When we talk at Tesla Tech tomorrow night with Steve, I'll share some of the results with that hashtag again.
Amazing, brother. Thank you so much.
Good night, everyone. Thanks for tuning in.
Lunar crystals. Thank you, guys.